All right, welcome back, everybody. I think I'm at like 92 subscribers, so we're very close to the 100 subscriber special. So, yeah. So tell your friends. You know. Okay. Yeah, please. Don't subscribe to Mr. Leverage. For everybody playing along at home, we dimmed the lights here in room 229 today. We've got a peaceful vibe going on. Yeah. Wish there was some like beach music playing in the background. Can you get maybe you? Oh, the rain stopped. The rain stopped. I was like, maybe they can hear that from home, but I guess. All right. Here we go. Solving systems of linear inequalities. You'll notice that we skipped section 3.2. We'll hit section 3.2 tomorrow. Don't worry. Sections 3.2 and 3.3 are independent from one another, so we could really switch the order and it's not going to change anything. But again, section 3.3 is solving systems of linear inequalities. I wanted to jump from equations to inequalities to show you the similarities and the differences. Can anybody tell me what the solution to a system of equations is? Like if I ask you, what is the solution to any system? What would you say? Like graphically. The intersection, right? The intersection of the two lines, where the two lines will cross. And we're going to go through all sorts of ways to find that intersection point, like we did graphing yesterday. Tomorrow we'll do substitution and elimination. Kind of talked about that already yesterday. But if I ask you now, okay, what if I change that into an inequality? You know, if I gave you, you know, y is greater than 2x plus 1, you would be able to graph that. You know, we tested that on the chapter 2 test. We said, okay, y-intercept of 1, slope of 2. You know, here we go. Dotted or solid line? Dotted line. Shade above or below? Shade above, because it's greater than, right? This is one inequality, right? So a system of linear inequalities is basically now just saying a couple of these on the same graph, one or more, right? I should say two or more. It doesn't make a system until there's two. So that's really what we have for a system of linear inequalities. It's a set of two or more linear inequalities with the same variables. Obviously, we're going to have x and y, same variables, right? But it's a system of two or more inequalities. Okay? The solution to a system of inequalities is often an infinite set of points, which should not be a surprise. Oh, there's kind of a glare on the board. Hopefully I can all see that. It's an infinite set of points, right? Which should not be a surprise because this is a solution of an infinite set of points, right? This point is a solution. This point is a solution. This point is a solution. This point is a solution, right? All of these coordinates over here are solutions to the inequality. It's an infinite set of values, okay? Now, but what we're looking at now is, if I put 2 on the same graph, it's got to be a solution to both of the sets of inequalities, right? Both of the two inequalities. Not just one, but both of them, which means it should be in what's called the overlapping shaded region. Okay, take a look here. Graph the system of inequalities. Y is less than negative 3x plus 2. Y is greater than or equal to negative 1. Okay, so if I want y is less than, now to graph this, don't use your calculators because I'm not really concerned with the intersection point now, right? It's not an intersection point, it's an intersection region. You'll see here. Y is less than negative 3x plus 2. So I'm going to graph the top line in blue, and then I'll graph the bottom line in red. Okay, the top line in blue. So if we've got y is less than negative 3x plus 2, well, the slope is negative 3, and the y-intercept is 2, so that's not too bad. Let's graph it. Make this just a little bit bigger. Y-intercept of 2, slope of negative 3, down 3, right 1, down 3, right 1. I could go up 3, left 1. Am I going to make this a solid or dotted line? Dotted line. Now, am I going to shade above or below? Below the line, less than. Remember that if you needed to, you could always pick a test point. Like, for example, 0, 0. If I plug in 0, 0, I'm going to get 0 is less than 0 plus 2. 0 is less than 2. Is that a true statement? Yes. So I'm going to shade on the side of 0, 0, which makes sense because I'm shading below the line, right? shade enough that you're going to be able to tell what the overlapping region is. What I mean by that is now I'm going to graph the other one. I'm going to graph the horizontal line. Oh, and I kind of let the cat out of the bag a little bit there. Isn't this a horizontal line? You know, if you're thinking about y is less than or sorry, greater than or equal to -1, if you think about y is equal to -1, that's a horizontal line at -1. So therefore, now I made it solid and I didn't even talk about it. Should it be solid? Yeah. Do a shade above or below? Greater than, shade above. Okay. Well, with my highlighter here, I'll make it this color. I wish it changed color when I overlapped the shading. I guess I could have, maybe I could have done this. Oh, that's not doing anything. Here, I'll do the purple. Oh, that's like black. Oh, yeah. I know. Can I do, what if I do this on top? Nope, that doesn't do anything. I'll just do, here's the overlapping shaded region. Yeah, there we go.
Wow.
Wow. All of those stars would be solutions. Right? You're looking for the overlapping shaded region. It's got to be a solution to both of them. This is, again, an infinite set of points. So if I said, what's the solution here? I'm no longer concerned with the intersection point. The intersection point doesn't really matter. It will matter again soon once we get to section 3, 4. But for our purposes here, it doesn't really matter. I don't really care where the two lines will cross. I care where the two shadings will cross. I care where the overlapping region is. Again, that means that if I picked any point in here, it would not be a solution. Because while it is a solution for y is greater than or equal to -1, it is not a solution for y is less than -3x plus 2. It's got to be a solution to both. A point down here would not be a solution either because it's while it's a solution to y is less than -3x plus 2, it's not a solution to y is greater than or equal to -1. It's got to be in the overlapping region. Any point in that region would be a solution because it fits both inequalities. Okay. Why don't you guys? Well, we'll do this one together. Why not? Because what do I have to do first? What do I have to do? Got to put them in slope-intercept form, right? I got to manipulate them into slope-intercept form. All right, so x minus 3y is less than 6. Well, that's going to turn into, we'll put this one in blue. X minus 3y is less than 6. Well, I've got to subtract the x over to the other side. Negative x plus 6. And then I divide by the -3. Don't forget, when I divide by the negative, I have to put the symbol here. Y is greater than. Now, I'm going to make that a positive 1/3 x. You could say x over 3, but that's not really going to tell you the slope. So I'm going to say a positive 1/3 x. And then divide 6 by -3 would get us -2. Y is greater than 1/3 x minus 2. Let's keep solving equations or inequalities here. I'll graph in a second. Here's my red one. 2x plus y is greater than 1.5. This one's nice and easy. Just subtract over the 2x. Negative 2x plus 1.5. So now these are both in slope-intercept form. Let's go ahead and graph. I'm going to make this a little bit bigger. The blue line has a slope of 1/3, but it starts at -2. So up 1 over 3, up 1 over 3, or down 1, left 3, down 1, left 3. The red line, oh, I forgot. Make it dotted. Oh, and I didn't shade yet. I'll use a yellow highlighter. Maybe that'll overlap. Greater than. Shade above. Okay, again, I'm going to try to shade as best as I can because I don't know where the other line is going to end up. I don't know where the overlapping region is going to be. So now when I go to my red line here, the y-intercept is 1.5. with a slope of -2. So down 2, right 1, down 2, right 1, up 2, left 1, up 2, left 1. Dotted line for that one as well. And now I want to shade above that line being up and to the right here. So now, let's see, will blue do it? There we go. Yeah, it does change. Okay, cool. Okay, yellow and blue. Work. So any coordinate in that green region would be a solution. Any coordinate. Any coordinate in just the blue? Nope. Any coordinate in just the yellow? Nope. Let me ask you this. Will the intersection point be a solution to the system? No. Because the intersection point would be a solution to if they would be equal. But these are unequal. These are not equal. One is they're both greater than, right? Neither of them are equal to. Okay, let's take a look here. Look at a word problem here. Lauren wants to paint no more than 70 plates for the art show. It costs her $50 plus $2 items, $2 per item to produce red plates, and $3 per item to produce gold plates. She wants to spend no more than $215, right? And graph a system of inequalities that can be used to determine the number of each plate Lauren can make. All right. So what we're going to be doing here is creating our system. And I will tell you this, guys. Creating the system is more difficult than actually solving the system or actually graphing the system. That's what you're going to find most often here. Creating the system is the difficult piece. Creating the system is the hard part. Okay, so let's create the system here. Lauren wants to paint no more than 70 plates for the art show. It costs her at least $50 plus $2 per item to produce red plates and $3 per item to produce gold plates. She wants to spend no more than $215. Okay, so I have two, thinking about inequalities, you got to think about limiting factors. I have two limiting factors here. What's my first limiting factor? What's my first thing that's kind of constraining me? I only want 70 plates. That's one of the things. I only want 70 plates. Okay, well, what are my two variables here? Red plates and gold plates, right? Okay, so let's define our variables. Let's say X is red plates, where Y is gold plates. Always good to define your variables. Set it up for the reader, saying, okay, I'm introducing X as my variable for the red plates. I'm introducing Y as my variable for the gold plates. Okay, well, if I wanted to do that, well, my limiting factors, one of them is the 70 plates. So I know that I have to stay underneath 70, right? I can't go more than 70 plates, less than or equal to 70. What goes on the left side of this inequality? Just X plus Y, right? People always try to make this one too complicated. Like start putting the money values in. No. The amount of red plates and the amount of gold plates together can be no more than 70. Okay, that's just saying X plus Y. Okay, what's the other limiting factor? Right, no more than $215 to spend. The money. So let's put all the stuff with the money. Now, can I spend $220? No, I have to limit myself to $215. So let's analyze the money stuff. Okay, it costs her $50 plus $2 per item to produce red plates and $3 per item to produce gold plates. So it basically sounds like she's got this $50 like to set up everything. And then for every red plate, it's $2. And for every gold plate, it's $3. So this will represent my total cost. My total cost. Now I left room. I left room because I'm introducing variables that could be anything that I really want them to be, right? What do I have to restrict the values to? like the x values. I'm saying if I introduce a variable, in my math world, x could be anything I want it to be. But to constrain it to my painting plates world, I have to do what? Only positives, right? Only positives. X has to be positive, y has to be positive. They could be 0 as well, though. So let's say x is greater than or equal to 0, and y is greater than or equal to 0. What does that do for me? It limits me to my first quadrant, basically. I know that seems like extra, like that seems extra stuff. It's not really, I promise. Okay. Now, when I solve a system of equations like this, when I'm working with word problems, how am I going to graph those? I tried to strongly suggest a way to graph word problems. Should I put them into slope-intercept form? Please say no. How would I graph them? You say you don't. Find the intercepts. Find the intercepts. Okay, so that's what we're going to do. I'm going to put this one in red. I got x plus y is less than or equal to 70. I'm going to graph that using intercepts. Hey, how about that? Each intercept is 70, right? So it's 70, 0, and 0, 70. If I let y equal 0, x is 70. If I let x equal 0, y is 70. And again, we do so by setting it as an equality and then going from there. Like I say, x plus y is equal to 70, and then evaluate. So 70 and 70 here and here. It's an or equal to, so it's a solid line. And now I shade below, right? Because it's less than or equal to that 70. If I plug in a 0, 0 here, that works as well. 0 is less than or equal to 70, which is a true statement. So I'll go yellow here. Okay. So here is my shaded region for the first constraint. Notice that I don't go into the, I don't pass my axes. I don't pass them because x is greater than or equal to 0 and y is greater than or equal to 0. Okay, so let's put my other one in green here. 50 plus 2x plus 3y is less than or equal to 215. Let's graph that one. Okay, well, to find the intercept, I need to set it as an equation, and I'm going to subtract that 50 over to the other side. It's going to help me out here. 2x plus 3y is equal to, so 215 minus 50. 215 minus 50. 165? I thought so. 165. And I'm going to solve that for my intercepts, okay? So if I plug in 0 for y, I get 2x is equal to 165. So I divide by 165 by 2, and I get 82 and a half. X is 82 and a half. If I plug 0 in, and so that means I've got 82.5 comma 0, right? If I plug in 0 for x, I get 3y is 165. So y is equal to 165 divided by 3, 55. So 0, comma 55. Again, graph using intercepts. You will be very happy you did that once we get to section 3-4. Because these points will be very, very, very important a little bit later on. So 82 and a half. The x value is 82 and a half. Oh, just a little bit beyond here. And then 55, right in the middle there. Okay. Ooh, a little curve at the end there. That's okay. Okay. So I go and I shade now. Remember that the shaded region is, if I plug in 0, 0 again, I'm going to get back to my original. 50 plus 0, so 50, is less than or equal to 215, which is a true statement. So I shade on the side of 0, 0. Okay. Looks green until I go away from the overlap. So my green region is my solution region. Okay, what is that telling me? That's telling me that any combination of plates within the green region would be a solution. Like, for example, would it work if I made 50 red and 10 gold? Yes. Would it work if I made 60 red and 10 gold? Still, yes. Would it work if I made 20 red and gold and 40 gold? Yes. Would it work if I made 20 red and 50 gold? No. Well, it would meet one of my constraints. It would not meet both of my constraints. Okay. Questions about that? Okay. Be very nice and neat with your shading. Okay. All right, let's take a look at this is the last one for you guys too, right? Yeah. So I just wanted to show you an example where there's more than two inequalities going on at the same time, and more than two inequalities. Like the first one, I've got 4 here, right? My suggestion to you is to use colored pencils on this homework. And even if you want to bring some in on that test quiz, I don't care. That's totally fine. Because it could get a little confusing if you're shading and then you have to overlap and you shade again and wait, I just overlapped my line and I can't see where my line was and I don't. So it might be a good idea to use some colored pencils on your homework. All right, so let's graph these one by one. I'm going to put the first one there in red. Y is less than or equal to 4. Okay, horizontal line at 4. Oh, I forgot to say this as well. One of my students a couple years ago said, how about this? What if we just do this so I don't have to shade? He was like, I really don't want to break out the colored pencils. I'm going to shade below that line. So I'm going to put little arrows on that line for the direction of the shading. Yeah, that's totally fine. And then in the end, we'll just go in and shade one spot, one overlapping region. The next one, let's put it in blue. Y is greater than or equal to -1. There's -1, and I'm going to shade above that line, right? Just put enough arrows on that line so you can tell where you're going to shade, because I really only want the overlapping region, right? That's the only solution region. Okay, let's take the next one in green. Y-intercept of 8 and a slope of -1. Again, a solid line. Shading below the line, because it's less than or equal to. See, I can just go in here and I know, see, I hope we're following along where the overlapping region is for now, right? The horizontal line's got us this row of shaded, right? And then now this green line coming across makes it look like this like trapezoid shape, right? And now let's put in our last one. We'll put that one in purple here. Y-intercept of 2 with a slope of 2. Rise 2, run 1, rise 2, run 1, down 2, left 1, down 2, left 1. And then I want to shade below that line. See down here. Okay, so now go in with a highlighter, pen, whatever you need to, and shade all of the overlapping regions. Look at all the arrows. They're all pointing into this piece here. Does that make sense? So that, therefore, you won't have like a bunch of different shadings going on. You can just do it once at the end. Yep. Okay, questions about that? Questions about that? Any questions on graphing inequalities? We're good? Cool. All right. So long, everybody at home.